So this is the uncompacted voids test, very simple. I think you saw it in the SAT too, was it? I wasn't teaching it, so I didn't say it.
But now you're teaching it.
Yes.
Good.
So, very simple. The test itself only takes about 5 to 10 seconds to run, but it's all in the preparation that you have to do ahead of time. So there's 3 different ways to prep your sample, A, B, and C. A is what you guys are going to focus on. So you're going to get the sample, whatever your material is. You're going to wash it, sieve it, dry it by T11, T27. You're going to break it into your different sizes. You're going to take different proportions here to build up to a 190 gram sample. So using this blend, this is the most efficient that they could find with spherical, as you said, with spherical ball bearings. This is the blend that gave the minimum voids.
190.
Yes. Yeah. So your sample's going to be 190 grams total. So 44 grams from passing number 8 retained on the 16.
How did you get that?
That's what
It just
when they originally developed the test.
Yeah, but like if I'm going to get my 190 grams together,
Yeah.
how do?
So you're going to wash your sample,
Uh-huh.
then you're going to do the sieve analysis on it.
Okay.
You're going
Then I'm
to
gonna
keep
take-
them separate.
Oh, okay. So I'm doing 3 sieve analysis.
Well, you're going to do the sieve analysis, but keep all the samples separate.
Okay.
So instead of just dumping it back in the same pan again,
Okay, you're gonna
keep them separate.
okay,
So
okay,
everything
that makes sense.
passing number 8 to what's retained on
And
the
then
16.
just weigh out 44 grams or whatever it is.
Exactly.
Okay.
So that you build up to 190 grams. That sample you're going to run twice,
Okay.
and take at least twice, but the minimum twice, and take the average, and that's the value you're going to get.
The same sample?
Same.
Yeah.
same
Okay, so we're not gonna have
exact
an A and a B sample?
Yeah, you don't have to have two.
Okay.
So you're gonna ask us what method we're gonna. Cause there's a. You said
Are we gonna?
a method A and B, right?
There's method A, B,
We're gonna
and
focus
C.
on A.
So we're gonna focus on A.
Yeah. B would
Always
be
focus on
if you
that.
separate into 3 different size fractions. Each one's going to be 190 grams. You run each one independently, maybe twice. I'm not sure, but for a good,
So we
for
just
good
need to know that we
practice,
have to
run
run it
each one
twice.
twice, and then you take the average of those 3. So U1, U2, U3. Take the average of that, and that's for your blend, for your material. Method C is if you're just testing it as is. So you receive a sample, you just want to test it as received. Just make sure it's passing number 4 and it's dry. But
Quick question.
Yeah.
We don't need to know 44 grams passing. Whatever.
I don't know it, so I would say look it up.
All right.
I'm just saying, are we gonna when we're doing a
Wait.
practical, we don't need to know that, right?
No,
Just the 190.
No, 190 is good enough.
I'll ask you, what kind of sample do you need to have? Just tell me that it has to be with a blend based on the different size fractions and this proportion. Good enough.
All right, could you just show us exactly just what we need to pass this test? Without all the questions, just basic what we need.
So then, after you got your sample ready, now you're going to calibrate the measuring tin here. So what you need to do is, we're going to use water, obviously, because it's easy. So what you do, I like to make a nice basic little sheet here, just to have everything that you're going to be measuring out and all your calculations. Just very simple. What are you going to do? You take this and take a little bit of grease. Use the bare minimum that you're going to need because will make
Don't want
less
to
to
get
clean
in the
up.
inside. It's going to change your amount.
Exactly. So just apply it to the top. I've been applying it a little bit heavy, so I've had to do some extra wiping just along the inside of the rim. But just make sure there's nothing in there when you're going to calibrate. So now what you do, you take this. So you want the measuring tin, the grease, and the glass. And you're going to measure those. Now you're going to pour in some water. The water has to be boiled under a vacuum and deionized because you don't want any air bubbles in it. And pour it in so it's just up above the surface tension holding it in. Don't pour in too much because you're going to have to wipe more up.
deionized or distilled, correct?
I believe so. You might want to check the spec on that or ask Tom tomorrow just to be sure.
Okay.
But the whole idea is you don't
Yeah,
want air
air-free.
bubbles. Exactly. So that you're going to use a glass plate because it's nice and easy to see through. You can see if there's any air bubbles. So you just come in. Okay. You look inside. You can see there's no air. Now you need to wipe it down because you want to wipe all the water off the outside.
Wait, I'm having a brain freeze. What is this called?
Uncompacted
That's right,
voids.
okay.
Uncompacted voids of fine aggregate.
That's right, okay.
You can also do it of coarse aggregate, but it's basically the same thing, but a much bigger
Larger,
setup. And
okay.
it's instead of using your
Uncompacted
finger,
voids.
it's got trap doors on the bottom of it, basically. So you take this,
You get that weight.
take that weight, and you can take the difference. That's going to give you your mass of your water. Then you're going to use your equation, V equals 1,000 times M over D. M being your mass in grams of the water here, D being the density in kilograms per meter cubed, but you have to look that up in spec T19. It's not just 1 gram per centimeter cubed. You actually have to look it up because it's based on the temperature. The water temperature should be between 18 and 24 degrees Celsius. Use 21 degrees Celsius. I believe that's what it is, because if you look on spec T19, it has a bunch of values in a table. If you're not testing at one of those values, you have to interpolate in between, and it's not a linear relation. So just use 21 degrees Celsius. It makes it nice and simple. So once you have that, come over here, dump the water out, clean the grease and the water off the glass. Make sure you clean the grease off the top of your measure here because you don't want anything left on it, and you don't want any of the sand to stick to it either, because it's going to stick to the outside and it'll change your volume. And then you need to wipe out all the water that's left inside because you want this completely dry. Now you're going to weigh this again, but just the measure. So no grease, no glass, no nothing, just the measure. Okay. So from here, now we're going to actually run the test.
Are we expected to weigh everything out and during the test?
Yeah, when you're running it, I would recommend weighing it down, writing it down.
All right.
So again, this is just very basic table, just all the values that you're going to be measuring out and calculating. It's just very simple. It's basically just follow the spec along, and you're setting it up the same exact way. But this makes it easy and convenient for you to run, especially if you're running multiple tests. But you come over here, there's a little hole in the bottom here, in the base, little set screw. Set it in place, so it's centered. Take a spatula, mix up the sample, make sure it's all blended, nice and homogeneous. And stick your finger on the bottom here, seal it up, pour this in. So you want to pour in the whole sample, and make sure this is in a tray here because you're going to retain it's going to go all over, and you want to retain all that material to rerun. Come in here with the spatula again, and you want to level it off. Just get it as best as you can. And you ready? Let it drop. You also want to make sure you have no vibrations, nothing mechanical running on the table that's going to compact this any more than just free falling.
From the specific height.
Correct. And this is a 115.
A specific height.
Yeah, it's a very specific height. They're all going to be calibrated to that.
Yep.
You can look it up in the spec to find out what the actual height is, but they're all run exactly the same. They're all built exactly the same. Then you come in, take your spatula, you're going to strike it off in one motion, and then I'm going to tap it on the side to consolidate it from there just a little bit, just to make it a little easier to handle and to clean up, but we'll have our full volume. There. Just give it a couple of taps. You can see it drops down just enough so that you're not going to spill it when you go to transfer it to the scale. But you also get a brush, and you just want to wipe off anything that's sticking to the outside or sitting on the base. Take your weight. Okay, and then the difference between that and the empty measure is the mass of just your sample. Then you can run it through your equation for uncompacted voids, which is your total volume that you got from the water and the calibration, minus the weight of the sample, F, over G, the specific gravity, divided by the volume, multiplied by 100. And that's giving you the percent of voids that are in this volume.
And the specific gravity is given to you from the supplier.
Correct. I believe so. Or you've
I
calculated
believe
it.
that's what I remembered.
Or you've calculated it out from an actual test.
Yeah, it's on the manifest. Specific gravity.
No, yeah, but generally speaking, the supplier will give you the specific gravity of the sample that you're getting.
Correct.
Right.
Yeah. Or if you're in a laboratory setting, you might run it on the sample and actually find it yourself. Either way, especially if you didn't know what it was to begin with, like you're doing it as received. Once you've done that, run the calculation. Very simple. Take it, dump it back in here. You want to clean this off, clean it into the tray.
Now imagine for the practical, we're only going to do it once, and then we're going to say we're going to do it.
Correct.
And are we doing all that calibration part for the practical too, or are we just going to tell you?
I'm going to check with Tom to see if
Okay.
he wants you to do that.
Talking through it.
Yeah, as long, from my perspective, as long as you can tell me everything, that's okay. But if he wants you to actually run through it and do it, we'll do that. It adds a few extra steps, so for the sake of time, we might not.
I was just going to say it's a time thing more.
Yeah,
than anything.
and it's just, and especially with the grease, you got the grease on you. And
That's what I figured. The person left after you left it all greasy.
exactly.
Oh, I'm gonna make sure you're out.
So
of
the
here.
test is over?
Put it on,
Test is over?
Yep, test is done, and now you rerun it.